good afternoon, morning, good evening, whichever time zone you're in. Okay, for this next question, we're going to complete the equation. Complete the equation. Balance it. Balance the equation. Of course, by doing the completion, you're going to do the molecular. That'll be the molecular. Let me finish this over here. Molecular. We will do the complete and the net ionic. Okay, first things first, I need to make sure that I know what's given to me. Okay, I could see that they give me barium. Okay, they give me barium nitrate. So barium is Ba based on my chart, and nitrate is NO3. I need to make sure that I know what's happening here. Barium is charge of 2 is in group 2. Nitrate is a polyatomic ion, and that is -1. So the 2 from barium goes to nitrate. I will do this. I have to. And it is aqueous solution, so I make sure I write aqueous just to be sure that everything is correct. Plus, I'm adding that or mixing that with aqueous solution of potassium, which is K, charge of +1. It is in group 1. And phosphate is a polyatomic ion. It's charge of -3. So K is for potassium, P of 4 for phosphate. The 3 from phosphate goes to potassium. There. That gives me a reaction. I will get a double displacement, and this metal will combine with this non-metal. Okay, so I go barium is Ba, phosphate is PO4. The 3 charge from phosphate goes to barium, and the charge of 2 from barium goes to phosphate. I make sure I do this. And what's left over is this metal with this non-metal, both charges of 1. That would be potassium nitrate. Okay, let's make sure this equation is balanced. And I have barium is 1 on my left, barium is 3 on my right. So let me do this. 3. Now barium is 3 over here. Barium is 3 over there. That's good. My nitrates, I have 3 times 2 on my left. That gives me 6 nitrates. But I only have 1 over here, so I'll do that times 6 over here. Now I have 6 nitrates. Good. So left and right are good. My potassiums on my left, I have 3 only. If I do this times 2, 2 times 3 gives me 6 potassiums. I have 6 on my right, and phosphate is 2 over here, and phosphate is 2 over there, so that's good. Okay, that's good. I need to make sure though that I tell whether it is something is aqueous or not aqueous. AQ over here, and the one that doesn't dissolve on my right side after the reaction is barium sulfate, so that would be the solid that stays together, and this is aqueous solution. Okay, so this is the molecular equation. All these crazy numbers that I did at the end, of course, it's not part of the equation. I'm just making sure that everything is balanced. Okay, let me erase all that so it doesn't confuse you. All that is not part of the equation. I'm just doing that to illustrate the balancing of such equation. Okay, I don't want to do that. I'm taking away those. So erase them. Okay, so this over here is my molecular equation. I've given you the complete equation. I balanced it. I said whether it is aqueous or not aqueous, and we're going to call this molecular equation. Okay, let's move on. Now let's do the complete ionic. Okay, the complete ionic is going to give me a breakdown of everything, such as I have barium is 3. I'm going to try to write small here. Barium is 3. I need to give the charge, which is charge of -2 or +2. Sorry, it is aqueous. Adding that with 2 nitrates. I have that 2 nitrates and 3, charge of 1 negative. It is also aqueous solution. Adding that with 6 potassiums, 6 Ks, charge of +1. It is also aqueous solution. Plus PO4. I have 2 of those. 2 PO4 charge of 3 negative as phosphate. Reaction will be, I need to keep the solid together. So I go Ba3 PO4, and that is 2. That's my solid reaction over here. And I have 6 Ks again, 6 potassium charge of +1, aqueous solution, and I have NO3s, 6 of them, charge of 1 negative. It is also aqueous solution. So this over here, the second equation, is my complete ionic. Complete ionic. Okay. What's going to happen, I will give you the net ionic. And the net ionic only uses whatever was used in the production of what's different. If you notice, here I have aqueous, 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 and I should have written aqueous here also on PO4. AQ goes there. Okay, my different compound is this. Okay, I will use that as my net ionic. What did I use? Okay, I went Ba3 PO4. 2 outside, it is a solid. Okay, what did I use to make that? I use 2 Bas, 2 bariums. Okay, charge of 2, and it is aqueous. And I use that with the addition of PO4. I use 2 PO4s. Okay, charge of -3. Therefore, and this is also aqueous solution, AQ. Therefore, I have barium on my left, phosphate on my left, and I ended up with the result of BaPO4 2 outside, Ba3PO4 2 outside is a solid. I'm going to call this the net ionic. So I just went over 3 different equations. I did my molecular equation, I did my complete ionic, and at the end I did the net ionic, which is the production of whatever is different. Okay, and that does it for this type of equation. I hope you have learned something from this clip. Thank you.